Hey guys, welcome to week 7 of DSGN121. This week we're going to be looking at assemblies. Previously, every time we've been creating models that have more than one part, we've just been creating them as new bodies within a single component. But what we're going to be doing is we're going to be making the next step, which is to actually make assemblies with multiple parts. So the first step in creating an assembly is to right-click your part and do a new component. This little box will pop up asking you what kind of type, internal or external. We want this to be internal because we want it to all stay within the same document. And then when I hit OK, you'll notice that this shape changes to essentially two blocks on top of each other next to another one. This implies that this is now an assembly. And every time I right-click this and create a new component, it will create new components underneath this. And for our exercise this week, we're going to be needing, looks like 3 or 4 components. So we'll go with 4. So I'm going to go ahead and create that 4 of those. And the important thing to understand here is that what we are going to be doing is a collection of fixed and unfixed parts. Essentially, like we've been talking about this whole quarter, everything that we're doing in CAD is a way to define something within a coordinate system. So previously, when we were creating multiple bodies within a single component, all we were doing was defining those bodies within that coordinate system for that component. Now we take that a step further and we can define where a component is within a assembly coordinate system. So it adds one more layer of definition. So the first thing that we're going to do is you always want at least one part to be fixed to the same coordinate system that the assembly is. So in this case, what we're going to be doing is we're just going to be taking our main body portion here. We're going to right-click it, and we're going to click this ground. And you'll get that little pin in it right there, and that implies that this is now ground fixed to the same coordinate system that the assembly is. So I'm going to call this the base plate. And we're going to go ahead and start with that. So again, what I'm just saying here is that these planes here and these planes here are lined up exactly. This origin point and this origin point are in the same spot. And that is what we want, because we want it to be just kind of where everything is based off of. The rest of these components I am not going to ground. I'm going to create them within the context of themselves, and then I'm going to use this assemble feature to assemble them to my base plate. And you'll see more about that when I get to that point. The other important thing to note when you are working with assemblies is that you have to activate your component that you are working on. So when you go up here, you'll see this option as I go to each one of them to activate them. This is so that the program knows which part of the assembly that you're working on. So if I create a new sketch and I want that sketch to be the base plate sketch, I want to make sure that I am activated my base plate so that the sketch is included inside of the base plate component. Otherwise, if I click on one of these other components, the sketch will go under one of those. Or if I'm in the assembly level and I create a sketch, it will go on the assembly, which cannot be used for the base plate extrusion in the part. So I want to make sure that I'm using the base plate. I'm going to activate it, and then I'm going to create a new sketch, and I'm going to use my front plane here, and I'm going to go ahead and draw this out. So I'm going to base this symmetrically about this line right here, like so. And I'm going to use the midpoint relation to snap the midpoint of that line to the origin. And then I'm going to dimension this based on the dimensions in the drawings that I will be providing to you guys. Oops, I just accidentally finished that sketch. I'm just going to go back and edit it. It is 140 by 175. And there is a pin that has a diameter of 6 that is located 22 and is going to be vertical relative to the origin. And that is actually everything that I need for the body. So I'm going to go into my solid, do an extrude. I'm going to click both profiles because I want to extrude the whole thing first. And I will go ahead and extrude this. Yeah, I'll just extrude this back. It doesn't need to be in the center of that for this particular one. Since everything else is going to be assembled to this, it doesn't really matter that this is lined up with that center. The thickness of this is 10, so we're going to go ahead and just set that to 10. And it is creating a new body, and we're going to hit OK. So before I said that you could have multiple bodies within a single component. That was okay for the examples that we were doing there. And I think I might have mentioned it back then, but I'll just say it here now. That is a modeling methodology. If for some reason you're trying to create something really quickly and you just want to make a component and just draw everything in the same context, that's perfectly acceptable. However, from this point going forward in this class, everything that you will be doing from now on will be in this sort of methodology, which is every single component should only have one body inside of it. You should, every time you have a separate body, that separate body should be a completely different component. So the rules are changing a little bit, and the reason for that is to help your learning with the basics. And so now I'm introducing the proper way of assembling components in which you should only have a single body per component. Okay, I'm still active in this component here, so I'm going to create another sketch, and I'm going to create it on that same plane. And actually, no, that's right, I can use the same sketch that I already did. So I'm just going to delete that second sketch because I don't need that. I'm just going to show the first sketch that I used, and I'm going to do another extrude, this time of this profile, and I want this to come out 5 millimeters. And it automatically joined to the other body. So I'm just double checking that I didn't create a new body. Go ahead and hide that sketch. And I've got my first part done. Okay, so now's a good time for me to save. So I'm going to go ahead and hit save. And I'm going to create a new folder. And this one is going to be called exercise 3. And it's going to be named last name underscore exercise 3. Okay. And now that I've saved that, I'm going to go ahead and work on my next component. And I'm going to hide my first component. And this is just to clean it up and make everything easier to work with. So you'll notice that I'm still working on the same coordinate system. However, there is a distinct difference that we will see in a little bit here. Firstly, I'm just going to go ahead and create the second component, which is going to be a crank. So I'm going to go ahead and name this crank. And I'm going to create a new sketch, make sure crank is the active component again, just double checking that. And I'm going to draw on the front plane. And this time, I'm going to draw this in the context of this grid rather than trying to draw it in place of where it's going to be positioned with the base plate. So in reality, the crank is going to be somewhere right around here. But instead of that, I'm going to be drawing it with the top circle portion here based on my origin. So I'm going to create that there. There's another one down here. And we've got a series of arcs. So I'm going to create a couple 3-point arcs. There's one there. And there is one over here. And another one here. And one more here. Okay. So I'm just going to draw those out first. And these are going to be both have the same diameter, so I'm going to make these equal. And I'm going to dimension those to be 6. Looks like I drew everything just a bit big. This point and this point. This whole thing here has a radius of 15. Yeah, okay, so I drew the whole thing way too big. So I'll just go ahead and shrink this up a bit. I'm going to make sure that those are horizontal relative to one another. And I'm going to make sure that this, relative to the origin, is vertical. I'm going to make sure that those are horizontal to one another and that these are equal, because those will be the same. And it looks like the center point of this on the drawing is actually going to be located under this. You will notice on the drawing that it is marked by just a little plus sign with a dimension. And the reason I chose this as the origin is because everything is dimensioned off of this point in the drawing. So I want to mimic that in my sketch here. Okay. And the distance between these two is 23. So it's going to be something a little bit more like that. And the dimension of these radius, and apparently these are all actually the same, is this is going to be 35. And that clearly is not what that's supposed to look like. So let's just back up there real quick. This one is actually supposed to be equal to this one as well. I'm fairly certain that this is going to be lined up in the middle of this one. And there's definitely some of this is not going exactly like I want it to. It's being very stiff. I'll try adding that dimension one more time, but I'm skeptical that it's actually going to work. I bet it's going to do the same thing that I was doing before. Interesting. Okay, so let's go ahead and tackle this then one curve at a time. And something that it's noticing here is that it's giving me degrees on these arcs. So what we're going to do is we're going to draw some construction lines that are coming off of this, like so. And we're going to draw these to the center of the arc, like so. And then this dimension here is going to be 60, as that is what is given. You will see in the sketch in the drawing that it only shows the points. It doesn't show these construction lines. The only way to possibly measure this is to draw construction lines to the center and essentially get that 60-degree slice out of that arc. Okay, so then we're going to go ahead and create our next arc. This one will not be a construction. So I'm going to go ahead and draw that one in. And this one is going to have the same arc points as well. So I'm going to go ahead and do the construction. And I'm going to go ahead and draw those two like so. And this angle is supposed to be 70. And the radius of this, and you can see that number is much closer now, is supposed to be 35. Like that. And I'm going to go ahead and create another arc. This one is not a construction arc. And this one are to be equal. Those should be level like that. And again, this just goes to show that sometimes you do need to define it first before drawing the whole thing. I usually tend to like to try to draw the whole thing before defining it, but here is a classic case of where that did not work, so I had to kind of walk backwards and take it a step at a time. So now that those are all equal, the last thing we'll need to do is just make sure that those are horizontal. Okay, so we can see here. That's how that's going. It looks like, yes, I believe this is sharing the same center point as this point. So we'll go ahead and make those coincident. And that fully defines it except for this. So we'll go ahead and just make those vertical. And that should fully define that. So now we've drawn our crank. And we're going to go ahead and take the main body here. Yeah, the main body there plus the top portion here. And we'll go ahead and extrude that. And I'm going to extrude it the opposite direction. And this one is going to be negative 10 thick, like so. And then I'm going to use that sketch again. I'm going to select it there. And I'm going to do an extrude. And I'm going to need to offset it because I want it to be on this side. So I'm going to go ahead and do object here, which starts the extrusion from a face or plane that you select, and I want it to start here, and then I want it to come out 5 millimeters, just like that. And I want it to join, so I'll hit OK, and then I'll go ahead and hide my sketch. And that gives me my crank. Everything there looks good, fully defined. Go ahead and drop that down, show my base, see where it is relative to the base there. That is eventually going to go on there once we actually made it in place, but we will come back to that in a moment. So we'll go ahead and move on to the next component, hide those two, and take a look at what our next component is. So our next component is referred to as a piston. So go ahead and type in piston. Make sure again that it is our active component. Create a new sketch, same plane, and same kind of execution here. This one I'm going to do a circle there, and another one down here. These are equal, and they are, we'll make this the 6 millimeter in diameter. And the distance from center to center is 75. And the center of this and the center of that are vertical. And then I'm going to draw another one on the outside of each. And these are going to be equal as well. And in the drawing, it says that the radius is 5, which means the diameter is 10. So I'm going to type in 10. And then what I'm going to do is I'm going to draw a line connecting these, like so. And I'm just making sure that it's making contact with the circle there, so you can see how it's coincident. And these will be horizontal relative to one another. Go and make sure I got those correct. And the width of this is going to be 4, as you can see there. And I could leave it like this, and this will extrude just fine. But just to clean it up a little bit more, I'm actually going to trim out those little connectors there, just to make it a little bit cleaner. And with that, I want to take this profile here with those being holes, and I'm going to extrude that. And I'll go ahead and keep extruding it the negative direction for now. And I'll make that 5 millimeters, so negative 5 millimeters. And that gives me my piston. Fully defined sketch. Looks good. Go ahead and hide the piston, move down to the next one. And the last component is going to be the piston tank. So piston tank is the name of the last one here. And this one is going to be based off of the same front plane. Again, making sure it's the active component. Create a sketch. Go to my front plane. And this one, let's go ahead and put this on. It's another thing that kind of looks like this. So we'll do a midpoint of the origin and the bottom line. Go ahead and dimension that width to be 30 and the height to be 35. And then this is going to have a pin in it. It's basically a mini version of our base plate. A diameter of 6, located 10, and it puts the dimension as 15 here, but that's just, I've already got it referenced as so. I guess we can leave it like that. Basically, I could have made that vertical as well. Either way would have worked. And then we're going to take this and that profile there and extrude them. We'll go ahead and extrude this one backwards as well. Negative 10. And then the sketch here, select that profile, do an extrude. Start of it is on the face of the object, and we're going to go negative 5. Making sure it's one body, fully defined, good to go. Okay, so now that I've got all of my pieces made, I'm going to go ahead and make my assembly the active component, and I'm going to turn on so I can see all of my parts. So now what you'll notice is if I click and I try to drag my base plate, it doesn't go anywhere. But if I click and I drag my other pieces, they're kind of floating around. There's nothing tying them down. Now the thing I was talking about early on at the beginning about the coordinate systems and how they are relative to the components now is that essentially if I wanted to go in and make a change to this one, even though I've moved it from the origin of the assembly, if I come over here to the crank and I go to create a sketch on the crank, notice where the origin is. The origin is still where it was relative to when I created the first sketch here. So that coordinate system has stayed with the component, even though I've moved it from the coordinate system from the assembly. So that's the important distinction there, is that the ground or fixed objects stay within the same coordinate system. They don't move. Everything else moves, and it takes its coordinate system with it. So go ahead and come back to our top level here, where we can start to assemble this. So we're going to start with the crank first. The way that you join objects together in this program is quite interesting. I don't love it, but it has its quirks, I guess. So what we're doing is we're going to be doing a joint, and I'm going to click the joint. It says some components have been moved as I drug all of this stuff around. If I hit continue, what it's going to do is it's going to bring them all back to the origin where I had moved them from. But I'm going to click capture position so that they stay where they are, so that I've got everything nice and spread out. The joint box here pops up, and we've got two tabs, position and motion. So motion has to do with what we want the joint to do. So for this crank is going to sit on this pin here, and I want it to revolve around that pin. So what I'm going to do is I'm going to select revolute, and then I'm going to come back to my position. And for my component, I have three options for the mode of which it is selecting: simple, between two faces, and two-edge intersection. This has to do with the type of joint that you were timed to create. Most of the time, you'll just be using simple. So the component one that I'm going to be selecting is, we'll go ahead and select this one first. So as you can see here, as I drag my cursor around, there's all of these little points around the object that it automatically snaps to. These are all the points where the joint can create a joint between this and something else. We want to use this tube here, and I'm going to select, and you can see here I can move through the tube as well. There's 3 points. There's the point at the beginning. There's a point in the middle of it, which is kind of hard to select, and there is a point on the opposite side, depending on what I'm trying to do. In this case, I'll just click this point here, and then now I'm selecting for component number 2, and I want to select the same point here. And when you see when I select there, it now moves this over here, and it now allows it to rotate freely. So if I hit OK on that, notice here that it rotates freely around that. One thing to notice here is that obviously my pin is not actually intended to sit flush with this face. So I'm going to need to make an adjustment to how I did that joint in order to correct that. So what I can do is I can go here, right click, edit the joint, and what I can do is I can actually offset it 5 millimeters from where I initially created that joint between the 2 points. So I just offset it, and then I'll hit OK. And then notice it's still fixed and can still revolve freely, which is what we want. Okay, now we'll go ahead and move to the next piece, which is going to be this piston. And I'm going to click joint again. Going to hit capture position so everything stays where it is. Make sure that the motion of this one is going to be set to something different here. So this one is going to be more of a probably something like rotates around and moves along a simple axis. Well, I guess we can try revolute and see if that works, and then we'll go from there. So I'm going to click that point there, snap it to this point there. That's what we want to see. hit OK. That one lines up perfectly, so that's good. And then I'm going to do it one more time. Do joint, and this one is going to be a revolute as well. So select that one there, and that one there. Actually, that one won't be a revolute, will it? We actually want this to be a slider. And it's actually going to be sliding up and down. So I'm going to hit OK on that. And let's see if I did it correctly or if I need to make some adjustments. Yep, definitely need to make some adjustments. So you can see there how it's misbehaving. So I'm going to go ahead and edit that joint, change it to a revolute. Still not working correctly. It does need to revolve, but it looks like what I actually need is I need to also lock it in another way. So the other thing I should try to do is try to do a joint. And let's see if this is the correct way or not. Between two faces. So this face and this face, this face, and this face, and this snap. No, that's not going to work either. Let's go ahead and back up here. Like I said, these joints are kind of tricky. They're a bit interesting. Let's try the planar. So the normal axis slide is the axes. Kind of hit OK on that. Yeah, nope, that needs to stay. Okay, so let's back up here because this is not working well. So this is working okay, but what I need is I need this to translate into a vertical motion. I think it needs to be a slider is what it is. And I think I need to define where it's located. So I'll go ahead and capture position. I'm going to do a slider. And I'm going to snap this to that. And the sliding is going to happen up and down. And you'll notice here that it's not really angled correctly. And I have a feeling that, yeah, that's going to give me grief. Oh man, that is not working well. All right, give me just 1 second to troubleshoot this and figure out how I need to make this joint. Okay, so my initial hunch was correct of something that I should have done. And so I will go ahead and show you how I did that, how I actually get this to work, as well as just point out one other thing, that capturing position is helpful for clearing stuff out of the way, but it also can be a problem when you're trying to line things up after the fact. So go ahead and make sure that when you do have those, once you've kind of got stuff figured out, you can go in and delete those captured positions and it shouldn't affect your joints at all. So I'm just going to say continue. And what I'm going to be doing is I'm going to be taking this back side of the piston part here, there, and the middle point of this, and you can see here how it rotates 90 degrees. So like there it's on the face, and then here it's perpendicular to that. I'm going to be clicking that, and then the motion type is going to be a slider, and I want it to go in the X direction, up and down, and I'm going to hit OK. And then the last thing I'm going to do is take and make a second joint. So the solution here was to create, I needed 2 joints in order to make this work. So then I'm going to use the revolute, select that, and select that. So that way it's revoluting on that. And then I'll hit OK. Everything is all green down here, happy as the clam. And then now that this is locked into only moving vertically up and down, which is what that first one was. However, this can rotate. You should have a fully functioning crank and piston, which is a nice example here of how a camshaft works inside of an engine and transfers that radial energy into linear energy. So just some of the fun things that you can do with joints. Once you've defined stuff in here, you can actually restrict it and test out mechanical operations, which is a pretty neat feature. All right, so once you're able to get that all together and you've got it all joint and you've got the piston there pumping correctly, you are done with the exercise for this week. So let me know if you have any questions on that, and hopefully that goes smoothly and you're able to learn a thing or two about how to assemble joints.